Hello student, today we are going to study about Van't Hoff reaction isotherm, or it is called as reaction isotherm also. At first, let us define what is Van't Hoff reaction isotherm. An equation which shows the relation between free energy change del G, standard free energy change del Z, degree del G naught, and the activities of the reactant and product of a reaction at constant temperature is known as reaction isotherm. Let us consider a general reaction. AA plus BB plus dot 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 gives, this is reactant side, and in the product side CC, this is small c dot capital C plus D dot, this is capital T plus dot dot dot. The change in free energy of this reaction is given by del G is equal to, del G means free energy is equal to summation of G product side, G of product, this is product side, summation G of product side minus summation G of this is of reactant side. That is del G is equal to this of product side minus and summation G, this is of reactant side, where Ga, Gb, Gc and Gt are the Gibbs free energy of A, B, C and D respectively. This Ga, Gb, this Gc, Gd are the Gibbs free energy of A, B, C and D respectively. We know is that Gibbs free energy is equal to G is equal to G naught standard free energy plus En RT ln P. And for A, we write AGA, AG not A plus ART instead of N, we write A, ERT, ln PA. Similarly, for B, C, and D, we can write respectively. Now we put values of AGA, AGB, BGB, CGC, and DGD in equation 1, equation A. We put the value. Look here, we put value of AGA, BGB, CGC, DGD in here, and we get the result like this. This is of reactant side minus this is a product side minus this is of reactant side. After here, and we take common CGC plus DGD minus AGA plus BGB plus CRT ln PC plus DRT ln TC, ART ln PA plus BRT ln PP. Then del G is equal to, this we take as one term, this is second term. Suppose this is we take B, this is we take A, then what you get is del G B, or you can treat this as a G2 minus G1. Then G2 minus G1 is del G naught plus we take RT common. Here is also RT, here is also RT, here is also RT, here is also RT. So we take RT common. At first RT common from here, RT, this is C ln PC plus D ln PD minus A ln PA plus B ln PC. This is at first small bracket plus big bracket is there. Then del G by del G naught plus RL ln, this from here we get PC plus PDT A PDT B. This is logarithmic function we applied here, and del GT is equal to del G naught plus RT ln PA, where which is the, this is where Kp is, this Kp is called equilibrium constant of the reaction. This whole term is called Kp, this whole term is called Kp, and which is called equilibrium constant, which is the required Van't Hoff reaction isotherm. In this way you can prove the Van't Hoff reaction isotherm. And now we'll study about significance. Sometimes the question is asked with the gives also show the significance of Van't Hoff reaction. At that time we should write this: when the activities of the species in the reaction is unity, then del Z is equal to del Z naught. When the activities of the species in the reaction is unity, when all the reactions this is unity, when this term is unity, then ln, when this all the term is unity, then what will happen here? Look here, uh, del Z is equal to del Z naught plus RT ln 1 we write, instead of kp we write 1, and from here what we get, del Z is equal to del Z naught plus RT, thus ln1 is 0, it gives 0 value, and once we get del Z is equal to del Z naught. In this way we can show that when the activities of the species in the reaction is unity, then del Z is equal to del Z naught. In this way we can prove at equilibrium constant, when the equilibrium is in constant, del Z is equal to 0. We take del Z is equal to 0, then del Z, this is the formula, of Van't reaction, and we put del Z is equal to 0, then look here, del Z is equal to 0, del Z naught plus RT ln K, this is Kp, this is Kp, yeah, then del Z naught plus RT ln Kp, this is Kp, and del Z degree is equal to minus RT ln Kp. This equation A gives the relation between standard free del Z energy, sorry student, and equilibrium constant. Similarly, look here, derive Van't equation of temperature dependence equilibrium constant. The question may ask, this is related to the Van't reaction, so we'll further derive it. When del Z is equal to minus RT ln Kp, prove that del ln Kp by dt is equal to del S degree by RT square. Then we know, what we know is that del Z is equal to minus RT ln Kp. When del Z is equal to 0, when del Z is equal to 0, then Van't Hoff reaction gives del Z degree is equal to minus RT ln Kp. Kp at equilibrium condition, this is we get at equilibrium condition, then ln Kp is equal to del Z degree RT, instead of del Z degree RT we keep is equal to minus 1 by R del Z degree by T. This is ln Kp, this ln Kp, this RT comes this side, then we get, what we get is that del Z degree minus, this is minus terms, and RT. Also this 1 by R is, we take one side, and this is 1 by del C by T. This is equation 1. Now differentiating equation 1 with respect to dt, we differentiate that equation, then we get d ln Kp by dt is equal to 1 by R del G degree by T del T. This is equation 2. We have, what we know is that del Z degree by T by dt is equal to minus del S degree by T2, and that is del S degree by, this comes this side, right hand side, this is it left hand side, we put it at right hand side, del S degree by T square is equal to minus, this minus side come this side, del Z degree by T del T by T. This is equation 3. Now we compare this equation 2 and 3. What we get is that comparing this equation 2, 3, and this is equation 2. When you compare this equation 2, look here, here is d ln Kp by dt, and in equation 3 we have got here is equal to minus 1 by R del Z degree by T, this is dt, here is also del Z T by dt, and when you compare this equation 2 and 3, we get the result, this del ln Kp by dt is equal to 1 by R dot del S, this is del S T square, here is 1 by R is 1 by R, this 1 by R comes here, and therefore d ln Kp by dt is equal to del S degree by RT square, which is the required expression for Van't equation of temperature dependence of equilibrium constant. Okay student, this question also asked, sometimes asked in 4 marks, sometimes asked in 2 marks, sometimes asked in 6 marks, and I hope you understand this. please like, comment and subscribe my channel so that you can get my other further videos. I hope you understand, and please give comments if you have any doubt. I'll try to solve all those comments. Thanks for watching videos, student.